Hey guys, what's up? Eddie Aho here with KISSanalog.com. This is another course at the KISS University called KISS-U 103, and I think we're going to call it Series Parallel Circuits with Kirchhoff's Law. So this is an introductory to Kirchhoff's laws, and also to kind of continue on with the series and parallel circuits, showing some schematics and what they are. So let's just jump into this thing, okay? Okay guys, last time we left off was KISS-U 102, and what we were talking about is series circuits doing power, doing energy, doing work. So doing work, what we're doing is we have voltage is pressure pushing down on the water. So we have voltage here, pressure, that's E, and we have current, which is water, a bunch of electrons, okay, and they're going through the pipe, that's our conductor, and we have current flow, okay, so this current flow pushes this water wheel, which creates energy, which is work. So energy is joules, measured in joules, and joules per second is equal to watts. So that's 1 watt is equal to 1 joule per second, okay? So just talking about that, and we're talking about how, you know, this is mechanical energy moving a wheel, and this wheel can turn electric motor turning into electrical energy. Kind of like a battery here can turn electrical energy, let's say it lights a light bulb, into thermal energy. So energy is being transferred from one type to another, okay? So then I drew a circuit here, and this is just our basic series circuit, okay? So what we have is our voltage source, and it's got a polarity plus minus. We're going to call it 1 volt, and then we have a resistor, 1 ohm, and I'm showing a series resistor because all the current that flows through this resistor also flows to this one and then gets back to where it came from. So that's a series circuit, okay? It's like if you're on a track in a car and you only had one place you could go, you're on a series track, and if that track gets stretched out, you know, more turns, whatever, it's still series. So in this case we had a R equals 1 ohm, and we added another one. So in a series circuit you just add them up, so you have 2 ohms. But then what we did is I'm showing Ohm's law, okay? What I want to show is Ohm's law will. Okay, you have E. This is kind of just an ISO trick of calculating Ohm's law. Just divide this thing up like this. Okay, so if you're trying to solve for I, you just cover up I, and it's equal to E over R. Okay, so then I run through this equation. I say E is equal to 1 volt, and R, if we only had this one, would be 1 ohm, would be 1, so current was 1 amp. But now when we add this one, then we added up 2 ohms, so it's 1 volt divided by 2, so now we have ½ amp, which makes sense, right? Because it's like restricting water. It's kind of like if this pipe was actually in 2 sections, and each one was like, say, equal to 1 ohm. And if you add 2 pipes, you're adding more resistance to the water flow, you get half as much water coming through. So that's what we're showing here, and this is an important thing right here. This is E, and over I times R. So for instance, if you know what your E is, then, or if you're trying to find E, then you go E, what is E? Well, covered up, and it's I times R. Okay, if you don't know what your R is, there you go. So you can go R, okay, Okay, so if you don't know what R is, you just cover that up, and then you say R is equal to, what is it? E over I, right? So E over I. So that's the three forms. This is 1, 2, 3. 3 variables, and you can put them in 3 different forms. Okay, that's just Ohm's law, basic series circuit. Okay guys, so here we are, KISS University, KISS U 103, series and parallel circuits with Kirchhoff's laws. Alright, so let's get into a series circuit, okay? Now what I want to show you is a symbol. Commonly used, we'll use it all the time. That's a symbol of, say, a battery cell, okay? Small, short plate and a long plate, okay? And we'll say this is 2 volts. So in your car, it's actually a 12-volt battery. It actually has 6 of these. In a lead acid battery cell, each set of plates gives you 2 volts. Alright? So if we're talking series circuits, then what I can do is I can just say, well, okay, so we're going to come down to another cell, okay? So in this case, we're going to say we have a 6-volt battery, okay? So I'll tell you what we're going to do is we're going to say we're going to power this car radio, which I'm going to show as a resistor. Okay, that's our load. We're going to say it's our load, and that's just our stereo, okay? And this stereo, I'm going to say it's a 100-watt stereo. Sorry, that's pretty crappy W. Alright, I don't know if I can fix that. Okay, 100 watts, okay? Then we're going to go ahead and connect it up. But you know what I'm going to do is I'm going to add some more battery cells, I think. So what I want to show you is you come along your circuit. I'm going, okay, let me show you the polarities, plus, minus. This symbol, the big plate is a plus and the small one's the minus. So again, remember that because the little one looks like a little negative sign and then plus. So this is the polarity of the batteries. Now this is a good example of how this plus and minus have nothing to do with each other. This minus has to do with this, because this is a potential difference between these 2 plates. This is voltage here, and it's plus to minus. This minus has nothing to do with the polarity of whatever this piece of wire is. Okay, it's negative in comparison to this, but in compared to this one, it's not. It's the same potential. It's the same voltage on this plate and this plate, right there. It's all the same thing. It's just nothing in between them. They're just connected together. Same here. So if you put your multimeter over here to read volts and you connect it here and here, you'd see 2 volts. You'd see, and if you put the red lead here and the black lead here, you'd see plus 2 volts. Red lead here, black, 2 volts. So if you put the red lead here, down here, you'd see 6 volts. Okay, so then I go plus, minus, plus, minus. Okay, got 2 more volts, 2 more volts. So I'm up to 2, 4, 6, 8, 10. So if I keep on coming around, I go plus, minus, this is 2 volts. Okay, that's my small plate, my long plate. Sorry, it looks terrible. Anyway, so as you go around this circuit, you're going to go plus to minus, plus to minus, plus to minus. So they all add up, right? Plus to minus, plus to minus, plus to minus. They're all in the same direction, so they all add up. So this circuit has 12 volts. So we can say ET, total voltage, is 12 volts. It's a series circuit. Now, as we come along here, the current, it's plus here, right? So the current, we're going to say the current flows this way, and the current comes down through, and as the current comes into resistor, it's plus, and then as it comes out, it's minus. So if you put your voltmeter here, you'd read 12 volts, right? Because you got all these things in series. It doesn't matter if we drew them all over here or spread out like that. And so then we have this, okay? So that's the same thing. It's an equivalent circuit, which what we like to do in electronics, do a lot of equivalent circuits. Let me show you another symbol. That looks like the cell, right? But if we put two cells together like that, that kind of symbolizes a battery with multiple cells. And we'll just call this 12 volts. So this is the equivalent of this. So equivalent circuits are really handy in electronics. And then we come and we do our resistor again, our load, okay? And this is RL. Same thing, same part. So now it's really obvious, plus minus. We put our meter there, it's plus 12. There's nothing magic about this wire, it's just a conductor. Just copper wire conducts electricity, right? So it can be 10 feet long, 10 inches, or 10 millimeters. It's